So let's move on to the last topic of our very first video, which is the parallel axis theorem. So parallel axis theorem is very common when we are going to find the second moment of inertia of the area. So for the theorem, for those theorem, it is a little bit difficult to explain in words, but let's illustrate you by using some examples. So before we introduce the example, let's talk a little bit. So Ixx naught, what does that mean? Just now we evaluated what is the moment of inertia of this rectangle. This axis is passing through its centroid, right? The moment of inertia of an area about an axis passing through its centroid will be Ixx naught. This is just an notation. I like to use this notation, but you may want to change it. That's okay. In fact, for different textbooks, there are different notations. So just check it out and see which one do you like. So maybe verbally we call it the moment of inertia of itself. Verbally, okay, it is not that formal. I just try to let you understand. So it is the moment of inertia about itself, an axis passing through its centroid. The moment of inertia of about an axis passing through its centroid. Okay. And now we are interested to, so for example, I named this axis to be x0, okay? Now we are interested to the moment of inertia of this region about another axis that is parallel to this axis, this axis is parallel to the axis that's passing through the centroid of this shape, and we are interested to the moment of inertia of this region about this axis. We call it x-axis. Well, maybe I call it A and B. Some of you might wonder, okay, I've already learned about double integral method, so I can do the double integral again to find the moment of inertia of this region about the x-axis. You may want to write, okay, it is Ixx equals to, so I call it L, okay, integral of the length L, and the integral from A to B, y squared dy dx. You may want to write the integral in this way, right? Because we have already learned the double integral method, but no, I'm not going to use this method. What I wish to introduce is that we can actually introduce the parallel axis theorem to get rid of using the double integral. What does that mean? I believe it has already taught in your year 1 physics course when talking about the math moment of inertia, but for the area moment of inertia, it is rather similar. You will have your entire area times the vertical distance delta y squared. Okay, so what does that mean? That means the moment of inertia about this axis equals to the moment of inertia of itself plus the area times the square of their vertical distance. This is talking about the moment of inertia about the horizontal axis. And similarly, if we are talking about, okay, so it is an axis y0, and we're interested to the moment of inertia of this region about y-axis, then you will have a horizontal translation delta x, the distance between the two axes, right? Then the moment of inertia will become the moment of inertia of itself. Moment of inertia of it about the vertical axis, which passes through its centroid, plus its entire area times the horizontal translation delta x. Then you will get the moment of inertia of this region about the y-axis. As you can see, it is